the direction of rotation is clockwise, then the angle is said to be negative angle. One right angle is 90 degree, 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds. The length of an arc of a sector is equal to r into theta. An angle subtended at the center of a circle by an arc equal to the radius is called 1 radian. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Now today in this session I am going to take very important chapter, that is trigonometric function. This is very important concept. Once if you are familiar with the trigonometry of first PUC, then it's very easy to solve the problems in your higher classes also. Now this is very important basic for trigonometry. Now let us come to the weightage. Before going to the exact chapter, let us know what is the weightage for trigonometry in first PUC. So in the examination they will ask trigonometry for 19 marks. This is very important and big chapter. So you will get one mark question and two marker questions, that is 4 marks, one 3 mark question and one 5 mark question and one essay type 6 mark question. So here you are going to get one 6 mark question in part E. In part E it may be a derivation of sin x plus y, sin x minus y, or cos x plus y, or cos x minus y. Okay. Now one mark question, one two mark questions and one 3 marks and one 5 marks and one 6 marks question. Totally the weightage for this is 19 marks. So you will get 19 marks from this chapter. Now let us come to the chapter now. Now in this chapter you are going to study regarding trigonometrical ratios, trigonometrical functions and the trigonometrical ratios for some standard angles, that is from 0 to 90 degree. Again the trigonometrical ratios from 90 to 360 degree, that is called allied angles. Then we are going to study compound angles, multiple angles, submultiple angles and the problems based on this and the solutions for some simple trigonometrical equations. Those are the things which we are going to study in this chapter. Now let us come to the first concept. What is the first concept we are going to study here? It is an angle. So before going to this angle, you might have been studied what is meant by trigonometry, what is the meaning of trigonometry. So why we have developed this? Actually this chapter trigonometry was developed mainly to solve the problems in astronomy. Nowadays we are using the concept of trigonometry in almost all fields of science and engineering. You might have been studied in your previous classes. Trigonometry means, the word trigonometry is derived from trigno and metry. Trigonometry. Trigonometry. The word trigonometry is divided into tri, gno and metry. So which in Greek tri means 3, gno means angles and metry means measurement. So 3 angle measurements. Measurement of a triangle or triangle measurement, that is nothing but comes under this trigonometric concept. So triangle measurement, 3 angle measurement. Now we are using this concept of trigonometry in almost all fields of science and engineering. You might have been studied those things in your previous classes. Now let us know regarding what is an angle and the measurement of an angle. What is meant by an angle? When did you say an angle is said to be generated? Suppose if an initial ray rotates, spills in any direction, in positive direction or negative direction, in upper direction or lower direction, an angle is said to be generated. That is, an angle is a measure of the rotation of a given ray about its initial point. The rotation of a given ray. Suppose if a given ray rotates in any direction about its initial point, then the origin ray is called the initial side and the final position of the ray after the rotation is called as the terminal side of the angle. Then an angle is said to be generated. The point of rotation is called the vertex. Here this is called the initial line, initial side, and this is called the terminal side. If this initial line rotates about the terminal, then an angle AOB is said to be generated. This point O is called the vertex. Similarly, if the initial ray OA tilts in this direction, this is the terminal ray, OB is the terminal ray, then an angle is said to be generated. So here, depending upon the clockwise and anti-clockwise, an angle is measured as positive and negative. So measured as positive and negative depending upon the rotation in clockwise as well as in anti-clockwise direction. If the direction of the rotation is anti-clockwise, then the angle is said to be positive, and if the direction of rotation is clockwise, then the angle is said to be negative. So here, this is a positive angle. So usually in trigonometry, we are going to represent an angle as theta. Theta is called the angle. Here theta is the angle. So therefore, AOB is equal to angle theta. This is positive angle. Here AOB is in the opposite direction. Therefore, this is called the negative angle. So if the direction of rotation is anti-clockwise, then the angle is said to be positive angle. If the direction of rotation is clockwise, then the angle is said to be negative angle. So here angle AOB is equal to positive angle. Here angle AOB is equal to minus theta, that is negative angle. So that means if this ray, initial ray, if this ray terminates, this is OA is the initial ray, if it tilts in any direction, then an angle is said to be generated. This is called an angle. This is called AOB, or AOB is called an angle. Okay, now you got an idea. Now the question is how to measure an angle. An angle can be measured in different ways. So here in this session we are going to study regarding radian measure, or it is also called a circular measure. Here we are going to express angle in terms of degrees as well as in terms of radians. So you might have been studied how to express an angle in degrees as well as in radians. Now let us come to measurement of an angle. So degree measure. So let us discuss regarding the degree measure. So if a rotation from the initial side to the terminal side is 1 by 360th of a revolution, then the angle is said to have a measure of 1 degree. Here, that is, if the rotation from the initial side to the terminal side is 1 divided by 360th, 1 divided by 360th of a revolution. So that means out of 360 revolution, one part, 1 divided by 360th revolution of an angle is said to have a measure 1 degree, then it is called as a 1 degree, and it is denoted as 1 degree. 1 degree is equal to 1 divided by 360th of the revolution. So a degree is divided into 60 minutes. So that means you might have been studied in segismal measure. There are different types of measurements: segismal measure, centesimal measure, and radian measure or circular measure. In segismal measure, you might have been studied one right angle is divided into 90 equal parts, and each part is called a degree. So one right angle is equal to 90 degrees. Again, 1 degree is divided into 60 equal parts, and each part is called a second. So one right angle is equal to 90 degree. Again, 1 degree is divided into 60 equal parts, and each part is called a second. Again, 1 minute is divided into 60 equal parts, and each part is called a second. This is called the segismal measurement. So here 1 degree is divided into 60 minutes, and 1 minute is divided into 60 seconds. So here 1/6 of a degree is called a minute. 1/60th of a degree is called a minute. So this is denoted like this: 1 minute, and 1/60th of a minute is called as a second, denoted as like this. So therefore, one right angle is 90 degree, 1 degree is equal to 60 minutes, and 1 minute is equal to 60 seconds. Okay, this is how we are going to express degrees in minutes and seconds. So 1 degree is equal to 60 minutes, 1 minute is equal to 60 seconds. Now let us define a radian measure. Now how to define a radian measure? A radian is nothing but an angle subtended at the center of a circle. An angle subtended at the center by an arc length 1 unit in a unit circle is said to a measure of 1 radian. This is very important definition. 1 radian. 1 radian means it is nothing but the angle subtended at the center of an unit circle by an arc length is equal to 1 unit. So here angle subtended at the center by an arc length of 1 unit in a unit circle is said to be a measure of 1 radian. So 1 radian means it is nothing but the angle subtended. 1 radian is nothing but the angle subtended at the center of a circle by an arc equal to 1 unit of unit circle. That's it. So an angle subtended at the center of a circle by an arc equal to the radius is called 1 radian, denoted as 1c. 1 radian or 1c, 1 circular measure. So very simple, an angle subtended at the center of a circle by an arc equal to the radius. Here OA is equal to 1 unit and AB is also, arc AB is also equal to 1 unit. Then the angle subtended at the center is called the 1 circular measure, that is called 1 radian, denoted as 1c. Now, hope you followed what is a radian. Now, let us come. Some of the angles whose measurements are, the standard angles are, for example, 360 degrees, 180 degrees, 270, 420, minus 30, 420 can be represented in the diagram like this. Now, how to represent 360 degrees? This is called 360 degrees. Complete one circle. So, that is 360 degrees. So, from starting point is 0 to same turn, same point. So, that one complete rotation will give 360 degrees. For 180 degrees, how to find 180 degrees? From A to B, that is a straight line. Here this is 180 degrees. Next, for 270 degrees, here this 270 is nothing but this straight line is 180 plus 90 is equal to this, up to this it is 270 degrees. Similarly, if it is 420 degrees means 360, this complete line plus 360 plus 60 degrees. So that is nothing but one complete, it starts from one rotation, again 60 degrees, that is nothing but 420 degrees. So here actually one complete rotation will comes for 360. This is 0 degree, 0, 90, 0 degrees, 90, then 180 degrees and 270 degrees or 360 degrees. Here it starts from this point, here complete, one complete circle, this will give 360 degrees. Okay. Now, 360 plus 60, 360 plus 60, that is nothing but this 60 will give 420 degrees plus 60. 360 plus this 60 will give 420. Now, similarly, if you want minus, so AOB in the downwards direction, that is, this is called a minus 30 degree. Similarly, for minus 420 here, the difference for plus 420, it starts from this 360 plus 60. Here it is in this direction, that is, it starts from here, completes on minus 360, again minus 60, that's equal to minus 360 minus 60 is minus 420. So these are the representations of the angles in diagram. So this is 360 degrees like this. This is also an example for 360 degrees, 180 degrees, 270 degrees, 420 degrees, minus 30 and minus 420 degrees. Now, come to the next concept, relation between the degree and the radian. Now, degrees and the radian. What is the relation between a degree and a radian? So here, since a circle subtend at the center, an angle whose radian measure is 2 pi. So, and its degree measure is 360 degrees. Here, from this we can say that 2 pi radians is equal to 360 degrees. So, if 2 pi radians is equal to 360 means pi is equal to 360 by 2 means 180 degrees. So, here pi radians is equal to 180 degrees. So, what is the meaning here? A circle subtend at the center an angle whose radian measure is 2 pi and its degree measure is 360 degrees. So therefore we can say that 2 pi radians is equal to 360 degrees or pi radians is equal to 180 degrees. So therefore pi radians is always equal to 180 degrees. This relation will help us to express the angles in degrees and radians. So to find the relation between radians and radians as well as the degrees. So here approximate value of pi is 22/7, whereas in trigonometry the value of pi is equal to 180 degrees. So therefore 1 radian is equal to 180 degree divided by pi, that is equal to 180 degrees divided by pi, that is nothing but 22/7. After simplification, the value is found to be 57 degrees 16 minutes. Approximate value of 1 radian is equal to 57 degrees and 16 minutes, and similarly 1 degree is equal to pi by 180 radians, that is pi by 180 radians is equal to 0.01746 radians approximately. These are the standard values. So 1 radian is equal to 180 by pi, that is nothing but 57 degrees 16 minutes approximately. Also 1 degree is equal to pi by 180 radians, means 0.01746 radians. So 1 radian is 57 degrees 16 minutes. 1 degree is equal to 0.01746 radians. This is the approximate value of 1 radian and 1 degree. Now the question is how to convert degrees into radians and radians into degrees. You might have been studied in your previous classes. Now let me take few examples to convert degrees into radians and radians into degrees. How to convert degrees into radians and radians into degrees? Now let us come to the first one. To convert degrees into radians. Degrees into radian measure. So this is very important formula. Now to convert degrees into radians, we are going to use the formula x degree is equal to pi x divided by 180 radians. This is very important formula indeed. So x degree is equal to pi x by 180 radians is a formula which is used to convert degrees into radians. Let us consider, for example, convert 30 degrees, 45 degrees, 60 degrees, 90 degrees, 180 degrees, 200 degrees, 270 degrees, 360 degrees into radians. Okay, let us come to the first one. 30 degrees. 30 degrees can be, what is the formula we are going to use? Pi x divided by 180, pi into 30 divided by 180. This 0 gets cancelled. 3 6 are 18. This is equal to pi by 6 radians. 30 degrees is equal to pi by 6 radians. Now come to the second one. 45 degrees. 45 degrees can be written as pi into 45 divided by 180. So 45 fours are, this is equal to pi by 4 radians. So pi by 4 radians is also equal to 45 degrees. Now let us come to the third one. Third one is 60 degrees. 60 degree can be written as pi into 60 divided by 180. 0 gets cancelled. 6 3s are 18. This is equal to pi by 3 radians. So pi by 3 radians is equal to 60 degrees. Now if you want 90 degrees, 90 degrees can be written as pi into 90 divided by 180, gets cancelled, 9 2s are, this is pi by 2 radians. 90 degrees is equal to pi by 2 radians. Next, 180 degrees. 180 is nothing but pi into 180 divided by 180. This 2 gets cancelled. Pi radians, you know, pi radians is always equal to 180 degrees. Now, next, 200 degrees. 200 degrees can be written as 200 is equal to pi into 200 divided by 180. 0 0 gets cancelled. So just divide by 2. 2 tens are, 2 nines are. This is nothing but 10 pi by 9. Now let us come to 270. 270 can be written as pi into 270 divided by 180. 0, 0 gets cancelled. So then this can be divided using just 9. 9 2s are 9 3s are 9 3s are 9 2s are. So 3 pi by 2. 3 pi by 2 is equal to 2. So finally 360 degree can be written as 360 degrees is equal to 360 into pi divided by 180. 18 2s are, this is equal to 2. So here this is how we are going to convert degrees into radians. This is the formula we are going to use, degrees for the conversion into radians. Now this can be represented in a table like this. So this is the relation between the degree measure and the radian measure of some of the common angles are 30 degrees can be written as pi by 6, 45 degrees is equal to pi by 4, 60 degrees is equal to pi by 3, 90 degrees is equal to pi by 2, 180 degrees is equal to pi, and 270 degrees 3 pi by 2, and 360 is equal to 2 pi. Okay. Now suppose if you want to convert, and let me take one more set of example to convert radians into degrees. So to convert radians into degree, what is the formula we are going to use? X radian is equal to 180x divided by pi degrees. So x radians is equal to 180x divided by pi. See in the previous one, pi x by 180, whereas this is 180x divided by pi. Let us consider for example, let me take one example, pi by 3 radians. Pi by 3 radians can be written as 180 by pi into x is nothing but pi by 3. Pi gets cancelled, 3 6. This is equal to 60 degrees. See here, pi by 3 is equal to 60, pi by 3 is equal to 60 degrees. So 60 degrees is equal to pi by 3 radians, or pi by 3 radians can be written as 60 degrees. Let me take another example, second one. Let us come to pi by 2. Pi by 2 radians. Pi by 2 radians can be written as, what is the formula? 180 by pi into x is pi divided by 2. This 2 gets cancelled. This is equal to 90 degrees. Pi by 2 is equal to 90 degrees. Suppose if you want to convert 3 pi by 2 radians, 3 pi by 2 is equal to 180 by pi into 3 pi by 2. So this pi and pi gets cancelled. How many times this will get cancelled? 2 9s are 90. 90 into 3. 90 into 3 is equal to 270 degrees. So this is how we are going to use the formulas to convert degrees into radians and the radians into degrees. Hope you followed this. So this is very important concept. So these things you might have been studied in your previous classes. The just revision of all those things. That's it. Now let us take few problems based on this. Now come to this example. Now in the examination they may ask like this for 2 marks or 3 marks. This is 3 mark per question. Convert 40 degrees 20 minutes into radian measure. Now to convert 40 degrees and 20 minutes into radian measure. So now what we have studied so far, we have studied the conversion of degrees into radians and radians into degrees. Now here the conversion of degrees and minutes, degrees, minutes and seconds into radians. Okay. Now listen, very simple. Here what is given? 40 degrees plus 20 minutes. Now here, now this 40 degrees as it is, now convert 20 minutes into degrees. So since we know that 1 degree is equal to 60 minutes. Now here 20 minutes can be written as 20 divided by 1 degree is equal to 60 minutes. So therefore this can be written as 20 divided by 60 degree. That's equal to 2 by 6 is equal to 1 by 3 degree. So this is 1 by 3 degree. That's it. Now take LCM. This is 40 plus 1 by 3. Take LCM. 3 is 4 is 12. 120 plus 1. That's equal to 121 by 3 degrees. 121 by 3 degrees is the conversion of 40 degrees in 20 minutes. Now, this is in degrees. Now, convert this into radians. So, how to convert this into radians? As I told in the previous, x degree is equal to pi x divided by 180 radians. Now, therefore, to convert, now therefore, 40 degrees 20 minutes is equal to 121 divided by 3 into pi by 180. So, this can be written as 121 pi divided by 180 into 3 is 540 radians. That's it. So, 40 degrees 20 minutes is equal to 121 pi divided by 540 radians. That's it. See, very simple problem. See here. First convert 20 minutes into degrees. Since 1 degree is equal to 60 minutes, so therefore this can be written as 20 minutes can be written as 20 divided by 60 degree. That is 2 by 6 is 1 by 3 degree. So 20 minutes is nothing but 1 by 3 degree. Simplify this, take LCM. So 120 plus 1 is 121 by 3 degree. So 40 degree 20 minutes can be written as 121 by 3 into pi by 180, because this is the formula we are going to use to convert degrees into radians. 121 by 3 into pi by 180, that's equal to 121 pi divided by 18 into 3 is 54, that is 540. So 121 pi by 540 radians is the required answer for this. That's it. Hope you followed. Okay. Now let us come to the next one. Convert 6 radians into degree measure. This is also an important problem. 6 radians. Since we know 1 radian is equal to 180 by pi degrees. So since we know this, 1 radian is equal to 180 divided by pi degrees. So how many radians we want to convert? 6 radians. 6 radians is equal to 180 into 6 divided by pi. So here just put the value of pi. Pi is equal to, since pi is equal to 22 by 7, you substitute here 180 into 6 divided by 22 by 7, that's equal to 180 into 6 into 7 divided by 22 degrees. So if you simplify this, we will get 343 into 7 by 11 degrees. Now let us convert this 7 by 11 into degrees, minutes and seconds. So therefore this can be written as 343 degrees plus 7 by 11 degrees. Now convert this 7 by 11. Simplify this 7 by 11 and add, that's it. So this can be written as 343 degrees plus 7 by 11 into 60 minutes. So what is this equal to? 343 plus 38 minutes plus 2 by 11. So this can be written as 343 degrees plus 38 minutes plus, for conversion of this we are going to multiply with the 60 seconds. 2 into 60 divided by 11. So since if you multiply 60 into 2 is 120 divided by 11, approximately 343 degrees plus 38 minutes plus 10.9 seconds. So this can be written as 343 degrees, 38 minutes and 10.9 seconds. This is the conversion, that's it. Or approximate value is 343 degrees, 38 minutes and 11 seconds. That's it. See here. So to convert 6 radians into degree measure, let us convert 1 radian is 180 divided by pi degrees. Therefore, 6 radians is equal to 180 into 6 divided by pi. That is nothing but 180 into 6 divided by pi is 22 by 7. 180 into 6 into 7 divided by 22. Now, if you multiply and divide by 22, so what is the thing we are going to get is 343 7 by 11. So 343 degrees plus 7 by 11 degrees. So convert this fractional part into minutes and seconds. So 7 by 11 can be converted into minute by multiplying by 60 minute. So 7 by 11 into 60 minute is equal to 38 minutes plus again 2 by 11 minute. So again convert this 2 by 11 minutes into second. So that is nothing but multiply by 60 seconds. 1 degree is equal to 60 minutes. 1 minute is equal to 60 seconds. So 2 into 60, 120 by 11 is approximately is equal to 10.9, that is 11 seconds. So that 343 degrees, 38 minutes plus 11 seconds is the required answer for 6 radians. That's it. Now, so in the beginning itself we have studied 1 radian is equal to 57 degrees into 16 minutes. For 6 radians, if you want, you can multiply with the 57 and 16 minutes. Definitely you will get the same answer. That's it. Okay. Next problem is find the radius of the circle in which a central angle of 60 degree intercepts an arc of length 37.4 centimeters. Use pi is equal to 22 by 7. Now actually here, now we might have been studied the length of an arc of a sector. So what is a sector? A part of a circle bounded by 2 radii and an arc. Suppose if this is O, A and B, if this is theta. So if AOB is a sector, OA is the radius, and this is the arc length, S is an arc length. The arc length S is equal to R into theta. We might have been studied the length of an arc of a sector is equal to R into theta. The same formula we are going to use here. What is given? Find the radius. R is the question mark of a circle which is a central angle. Theta is given. Theta is equal to 60 degree means this is equal to pi by 3 radians. Intercept an arc length S is equal to 37.4 centimeters. Use pi is equal to 22 by 7. Now we know that what is the formula for arc length? S is equal to R into theta. 37.4 is equal to R into theta is pi by 3. Okay. Now simplify this, you will get the answer. That's it. So therefore R is equal to 37.4 divided by pi by 3. So what is this equal to? 37.4 divided by pi by 3. Pi is equal to 22 by 7 divided by 3. This is equal to 37.4 into this goes to the numerator. 22 by 7 into 1 by 3 is 22 by 21. So this goes to the numerator. 21 divided by 27. If you simplify this, the answer for this is 35.7 centimeters. So this is the required 35.7 centimeters is the required answer. So this is 37.4 into 21 divided by 27. See here. Find the radius of the circle in which the central angle of 60 degrees intercept an arc length of 37.4 centimeters. So we know the formula length of an arc of a sector S is equal to R into theta. Here R is the radius that is to be determined. Theta is 60 degree means pi by 3 radians. S is equal to given 37.4. Since what is the formula? S is equal to R into theta. 37.4 is equal to R into pi by 3. Or what is required to find is R is equal to, or if you want you can straight away write here, R is equal to S by theta. So S divided by theta, 37.4 divided by 22 by 7 divided by 3, that's equal to 37.4 into 21. So that is, this is nothing but, I'll write again here, 37.4 into 21 divided by 27, that's equal to 35.7 centimeters. This is the required answer. Okay. Now let us come to the next problem. The minute hand of a watch is 1.5 centimeters long. How far does its tips move in 40 minutes? This is also important. So the minute hand of a watch, is 1.5 centimeters long. How far does its tip moves in 40 minutes? So how far it will move in 40 minutes? This is to be determined. This is theta, this is S, this is R. To complete one revolution, it is going to take 60 minutes. Okay, so therefore, in 60 minutes, it will take one revolution. So, whereas in 40 minutes, it will take 2/3 of the revolution. 2 by 3, okay, in 40 minutes. Therefore, here theta is equal to 2 by 3 into 2 pi. That's equal to 4 pi by 3. Now, find out the value. What is required? How far does its tip moves in 40 minutes? How far does its tips moves? That means this is to be determined. S is the question mark. R is given. What is the radius? Radius is 5 centimeters. R is equal to 1.5. S is equal to question. Now we know that S is equal to R into theta. So therefore, R, what is R? 1.5 into theta. What is theta? 4 pi by 3. Now substitute here. S is equal to R into theta. Yes, R is 1.5 into theta is 4 pi by 3. Substitute the values. This can be written as 1.5 into 4 into 22 by 7 whole divided by 3. So after simplification, this is 1.5 into 4 into 22 divided by 21. This is equal to, the required answer we are going to get is, after simplification, 6.28. 6.28 centimeters. Otherwise, you can substitute 1.5 into 4 by 3 into pi is equal to 3.14 and simplify. You will get the required answer as 6.28 centimeters. That's it. Very simple. See here, what is the problem given? So here the minute hand of a watch is 1.5 centimeters long. This is 1.5 centimeters long, the minute hand. How far does it tips moves in 40 minutes? So this, the distance traveled, S is to be determined. Here, since for one complete revolution it will take 60 minutes. So for 40 minutes it will take 2 by 3 revolution. So therefore theta is equal to 2 by 3 into 2 pi radians. So this is equal to 4 pi by 3. Hence radius is given, R is equal to 1.5. Therefore S is equal to R into theta. 1.5 into 4 pi by 3, that's equal to 1.5 into 4 into 22 by 7 by 3, that is 1.5 into 4 into 22 by 21 is equal to 6.28 centimeters. Now, let us come to the next problem. This is also an important problem. If the arc of the same length in two circles subtend angles 65 degree and 110 degrees at the center, find the ratios of their radii. Now, what is required to find here is, suppose if R1 and R2 are the radii, then it is required to find the ratio R1 is to R2. This is to be determined. Now, what is given? The arc of the same length in two circles. Suppose if S1 and S2 are the length of an arc in the circle 1 and circle 2, and it will makes an angle theta 1 and theta 2. What is given? Theta 1 is equal to 65 degrees and theta 2 is equal to 110 degrees. So, S1 and S2 are the same lengths in two circles where theta 1 and theta 2 are the angles. What is required to find is the ratio of the radius R1 is to R2. So, what is given here? The same lengths in the arc lengths are same. That means these two are equal. Yes, S is equal to S1 and S is also equal to S2. So we know the formula, we know that S is equal to R into theta. So S is equal to, for the first circle, it is R1 into theta 1, that is also equal to R2 into theta 2. Substitute here, that is R1 into theta 1. Now convert theta 1, 65 and 110 degrees into radians. Now theta 1 is 65 degrees. 65 degrees is equal to 65 degrees into pi by 180. So this is equal to 13 pi divided by 36 radians. Similarly, let us come to the second one. Theta 2, 110 degrees. 110 into pi divided by 180. This is equal to 11 pi by 18 radians. So theta 1 is 13 pi by 36, theta 2 is 11 pi by 18. Substitute here, that is R1 and R2. R1 into theta 1. What is theta 1? 13 pi by 36 is equal to R2 into theta 2 is 11 pi divided by 18. Simplify this into R2. Now what is required to find is the ratio. So that is R1 by R2 is equal to, bring this to the denominator, this is 11 pi by 18 and this goes to the numerator, 36 divided by 13 pi. So pi and pi gets cancelled. How many times? 18 2s are 36 and what is remaining is 2 into 11 is 22 divided by 13. So therefore the ratio, therefore R1 is to R2 is equal to 22 is to 13. That's all. Okay, hope you followed. See here, if the arcs of the same length, S1 and S2 are same, R1 and R2 are the radius, theta 1 and theta are the angles given. What is required to find the ratios of the radius? R1 is to R2. Now since we know that S is equal to R theta, S is R1 theta 1 is equal to R2 theta 2. Convert theta 1 65 degrees and the theta 2 110 degrees into radian. That's all, and substitute. Theta 1 is 65 degrees. 65 degrees can be converted as 65 into pi by 180. That is 13 pi by 36 radians. Similarly, theta 2 110 degrees. 110 degrees is nothing but 11 pi by 180. Substitute here. R1 into theta 1 is 13 pi by 36. R2 into theta 2 is 11 pi by 80. So what is required to find is the ratio R1 by R2 is equal to 11 pi by 18. Bring this to the denominator. 13 pi by 36. It goes to the numerator. Pi gets cancelled. 18 2s are 36. 11 2s are 22 by. So therefore the required ratio, therefore R1 is to R2 is equal to 22 is to 30. This is the required answer for the problem. So the required answer is 22 is to 30. That's it. Okay. Hope you followed. So these are few problems based on the conversion of degrees into radians, radians into degrees, and to measure the length of an arc of a sector. So these things you might have been studied in your previous classes, the revision of those things which we have carried in this first session. Okay. That's all for today's session. Let us meet with a different concept in the next session. Thank you. Thank you very much.